running those tests. Great, 6 tests passing. Hey guys, Thomas here from EthereumBlockchainDeveloper.com, and in today's video I want to walk you through an ERC721 setup with an actual physical supply chain component attached to it, which we are using for our projects STZ. If you haven't seen that, then head over to stz.art. We are launching our own NFT in cooperation with 10 different artists around the world. And for that, we need an actual NFT. So let's go. Okay, as you can see here, I am on the Ethereum-blockchain-developer.com website, and you can find the ERC721 with physical asset shipping later on in over here on the left side, where we have the menu right next to proxies and upgrades. It's not in there yet because it's not 100% finished, but you can also find it on our project's STZ Medium post, and there is a technical deep dive, and that links back to this article over here. When I click here, well, I'm back here. Yeah, so let's get started. What is going on in this video lab today? We are going to talk a little bit about how the smart contract is going to be set up. We are going to install Truffle and initialize a new Truffle project. We're going to add in the OpenZeppelin smart contracts. We are doing an ERC721 preset minter pulsar auto ID, and I'll tell you how that works internally. Then we are, deploying that to a local blockchain, and we are going to interact with our smart contracts a little bit. Then I want to talk a little bit about the time-based locking mechanism, and we are going to hook into the token transfer functionality. And then we are writing a unit test at the end, which basically tests the whole functionality from start to finish. Okay, there's not a lot of time that we have to spare, so I would say we get started. And before we are setting up Truffle, I want you to be fully aware of what we're actually doing. Otherwise, it wouldn't make any sense to set up Truffle if we don't know what we want to do. So obviously, our NFT is going to be slightly different from the rest of the NFTs that are out there because it has a digital component and a physical component attached to it. So we are going to auction a digital art piece that is going to happen between July and October. And then we are taking the digital art and printing it as a label and putting it on a bottle of olive oil. And at that time, the NFT is going to get time locked, and you need the actual olive oil, which we're going to ship. And then you need that actual olive oil, and there's a QR code on it to actually unlock that NFT again. There are a couple of challenges here, and besides that, it's managerial challenges because we have 10 artists, and everybody has different ideas when it comes to digital art and physical art, and and so on. But there is also the authenticity of the owner of the NFT, so who to ship to, and that needs to be a trustable address. So we need some sort of verifiable, cryptographically verifiable shipping address mechanism, which we are currently developing. And we also want to attach a video and to the NFT from the harvest and so on. So the video is known up front. We don't know if the harvest is really going to be like super amazing or just normal. I would assume everything goes well, that we have 10 bottles, cannot much go wrong, but still there's a physical component of a harvest that actually takes place in the future attached to that, and so on. So a lot of things can go wrong. So how are we going to do that with the authenticity and the shipping? Because if you are coming from a physical supply chain world, then that is probably the most interesting. We are generating the token, and you can, like any other NFT, you can transfer the token around until October 1st. And then the token gets time locked. There's a time lock, a novel time lock mechanism in the token that we're going to develop together later. And we are going to ship the bottle with an unlock QR code, and the owner scans that QR code later on, and he can transfer again the token freely, basically forever. It is proof of delivery, and that's it for us. Yeah. So I would say we get started with the actual token prototype. If you haven't installed Truffle yet globally, then install Truffle. Basically, I head over to my console over here, terminal, new terminal. That's should be fairly the same on every system. For Windows, it's the PowerShell. Linux and macOS is a terminal. So, and then you just type in npm install -g Truffle. That will install Truffle. I already did that. So I'm going over to the next step. That is Truffle init. That will initialize a new Truffle project. If that errors out with some sort of Git problem, then install Git first. And then we install the OpenZeppelin contracts. What are OpenZeppelin contracts? OpenZeppelin contracts are contracts that are audited and are basically industry standard, smart contracts, really nice to use, well structured and so on. Okay, now we have our OpenZeppelin contracts here in the node modules folder, node modules /OpenZeppelin /contracts. VS Code is automatically opening that folder. And here we have tokens, and we have the different tokens, and we are using the ERC721, and we are actually using this preset, which allows us to mint, to pause, and give every token an auto ID, and so on. So it's fairly easy to use. Okay, it's time to generate our first contract, and we are creating a new file as the Z token in this case in the contracts folder, and I'm just copying this here, and I'll walk you through the things in a second. So I'm going to our contracts, I'm creating a new file, calling it SDZ token solidity, and I'm pasting the contents from our walkthrough. So what it does is it imports this ERC721 preset minter pauser auto ID, and it also imports a counter. The counter is something that we need later, and you can basically remove that over here for now. And what it does is it extends the ERC721 preset minter pauser auto ID and creates a new contract called SDZ token. And in the constructor, it basically gives the preset the token name, the token symbol, and an address or a URL where you can find the JSON metadata. And the only other thing that I would very much like to do is because it would just give you, if you take the token URI, if you want to know where the JSON is located at, it would basically give you back https://sdz.art/metadata/0 for the first token, /1 for the second token, and so on. But there is no JSON attached, so I just attach a JSON to it. So when we are calling token URI, then it will automatically give us a JSON URI back. Yeah, that's the token. And then we need to somehow deploy that. So we need a migrations file, and then I'm just copying that one and click here, and I create a new file, to_token_migration.js. to_token_migration.js, and I'm gonna paste that in here. So Truffle now knows it. We want to deploy the SDZ token. And then the next part is we need to tell Truffle that it should use the version 0.8.3, and I actually want to enable the optimizer. Can leave it disabled. It's your personal choice. So the only thing that we really need to change here is that we want to use the version 8.3, and you can enable the optimizer if you want to. I just leave that disabled for now. And then we can open the Truffle development console that gives us conveniently an environment where we can migrate our smart contracts, deploy them, play around with them. So I'm just hitting migrate for now. Forgot to save my token. That's interesting. So if you get this, don't forget to save your file. Yeah, the token is deployed on our test network or development environment here. So now we can interact with our token. We could, for example, send one token from one address to another address, like mint one, and then get one. So the way we get the token instance is await FTZ token.deployed. That will give us an instance of, did I make a mistake here? That will give us an instance of the STZ token contract. So when we do token now, then we see there's the whole token contract with everything that we want, including all the functions that our token has and everything that it got from the ERC721 preset minter pauser auto ID. When I open this one, you can see there's a mint functionality, there's a pause functionality, there's an unpause functionality, and we have all these functions, including the ones that the preset got from inherited from the contracts that it extended. So we can, for example, mint a token for us or for our another account if you want to. I'm just minting it for us, and we get a status. Where is it? Status true. That means the transaction went through, and then we can transfer it to the first account in our accounts array. So from our accounts, we just minted the token to the first account, and then we transferred it to the second account, the token ID 0. So it starts with 0. And then we can give us the balance of the tokens for our account 1, and we know that we have 1 token in there, and it returns 1 token, so everything is fine. We can interact with our smart contracts, and everything seems to be working just fine. So how about this time-based locking mechanism? The way we want to do that is that we are locking, or we are not allowing any transfers from a specific timestamp onwards, unless somebody provided a passcode or a hash of a password. And the way we are doing that, if we have a look at the ERC721 preset minter pauser auto ID, then you will find that it calls, before it actually transfers a token, it will call a before token transfer function. So this is where you can actually hook into the whole transfer flow and allow to make certain checks or prevent transferring, essentially. And what we're doing here is we are requiring that the token locked from timestamp for the specific token ID that somebody tries to transfer is in the future. And if it's in the past, then it will just not allow this, and this one will evaluate to false. And we are allowing transfers only then if the token unlocked mapping, there's a mapping that is going from a token ID to a Boolean value, is true. Otherwise, it will tell us, hey, STZ token, the token is locked. If that whole thing evaluates to false, the transaction will abort here. If that evaluates to true, then it will just call the before token transfer from the next contract in the inheritance chain. Okay, how do you get your actual token unlocked? By calling unlock token, and that is with an unlock hash. And over here, we are going to double hash our password. So what we're going to do is we have an unlock code, and we are hashing that. And the hash of the unlock code is the content of the QR code later. And the hash of the unlock code is going to be baked into the blockchain for a specific token in order to unlock it later on. Yeah, and if you provide that hash of the unlock code over here, then it will just check if the unlock hash hashed is the same as the in the blockchain baked unlock code hash. And if that is true, then it will just unlock the token, emit an event, and fine. Minting has also changed a little bit because now we want to provide an unlock hash and a lock timestamp from. If you have a look at the function that is in the minter pauser auto ID preset, the mint functionality just tells like, hey, give us an address where you want to have the token minted to. And if you are a minter, then basically just give that person a token with a specific token ID, and that is coming from this counter value here. Yeah, so how are we going to use that now? We are going to extend our smart contract with this functionality. Basically, copy it and paste it over here. Don't forget to save. And then we are migrating this with the reset flag. So now we have the new token here, and then we can say the token dot deployed. So we have the new token instance, and we are going to mint one token for our account 1, but it's going to be locked 3 seconds in the future. And the unlock hash is going to be the hashed version of my secret hash string, whatever. You can use anything you want here. So I'm just copying this row here. And then if you're going to check the mint.receipt.status, then we see the minting has been done and successfully minted this transaction. So next we want to transfer it from account 1 to account 2. And that one fails. And the reason is the token is locked because it took us longer than 3 seconds to actually transfer that token. So we can now unlock the token with the hash of my secret hash. Oh, that was wrong. Actually, let me copy that whole thing here. Okay, that is a status true. And then we can transfer it further, like to anyone we really want to transfer it. And just see if the status is true. Yes, so the token is unlocked. We can transfer it around now. Proof of delivery, somebody scanned the QR code over here and somebody created this transaction through a web interface that we are going to provide, obviously, with the hash of the code that we baked into the blockchain. Okay, who is the token owner of the token ID 0 now? And that is, if you have a look at the accounts array, that is account number 2 because we transferred it from account 1 to account 2 in that line over here. Yeah, the last thing is what we want to do is we want to unit test everything. And that is basically the same thing that we just manually entered in the Truffle Developer console over here in a unit test. I'm just copying this now and I'm walking you through this file in a second. So I'm creating a new test here in the test folder and I'm calling it unlocktoken.test.js. I paste everything and I have one unit test here for the SDC token contract. It's possible to mint token for the minter role. So when we are creating the token, then we get automatically the minter role. I think that should be fairly straightforward. We are minting, we are asserting that it fails. The transferring for others are not working, but it passes that the token holder can actually transfer the token. So meaning we are minting one token for one address, which is not the deployer address, and somebody tries to just transfer from the deployer address to the token holder, but the deployer address doesn't have a token yet. It's on the token holder address, so the token holder 1 address can actually transfer it away. Next test is it's not possible to transfer lock tokens. So that is the thing that we did before. We are minting the token with 3 seconds in the future a lock period. So that's that one. And then we are waiting 4 seconds and now the time has passed. So now it fails that we can actually transfer the token away. Now it's not possible to unlock the token if you are not the token holder. So not everybody can unlock the token just because they got the QR code. Only the token owner can unlock the token with the correct code. So it fails if you put in a wrong code, but it works if you are unlocking the token and then you can transfer it. And you can also retrieve the correct token URI. So if you're just typing in test here, then it should actually run this test. Oh, I need to save this file, of course. Oh, one thing that we have to install first is the Truffle assertions. So let me go out here into the normal terminal and just npm install Truffle assertions. That's a neat library from a smart guy who saw that making assertions with Truffle is really annoying. So he wrote this Truffle assertions npm library. Go check it out and use it for your own projects. I'm using it for mine. It is really cool. And now we can basically just say Truffle test directly here. And it should just go through these tests. And we are done. Running those tests. Great. 6 tests passing. That's what we want. And that basically concludes our part here about setting up Truffle with an ERC721 token and hooking into the actual token logic to avoid any transfers if we don't want them to transfer. So basically, there's a standardized way, an interface that OpenZeppelin gives us to actually hook into the transfer flow, and that's what we are using. Then we are writing unit tests for everything. Always write unit tests for your smart contracts. It's absolutely necessary. And then we are testing it, and that's it for part 1. Now, one thing that you have to keep in mind is if you're using this pauser preset, then you can also pause and burn tokens. That's not necessarily something that you want. So in the next part, we are going to simplify our token contract with our own low-level ERC721 contract from OpenZeppelin without any presets. And then we are using those to basically save gas and have only the functionality that we really need. All right, follow our project, follow us, chat with us on Discord, follow us on Twitter and so on. Like this video, give us a thumbs up, and I hope you found this useful, and I will see you in one of the next videos.